This is a problem from section 4.1, your lab assignment. It says they want us to find the absolute maximum and absolute minimum values of f on a given closed interval. So your f function is 2 times x cubed minus 3 times x squared plus 36 times x plus 8 on a closed interval from -3 to 4. The first thing we want to do is we want to find the absolute maximum and minimum. We want to find the critical values, and we're only interested in the critical values within the interval -3, 4. And so to find the critical values, we need to take the derivative. So let's take the derivative of this. This is a polynomial, so it should be fairly easy. We got 6x raised to the second power, and then we have a minus 6x, and then a minus 36, and then plus 0. So this is our derivative. Now we're interested in setting this equal to 0, so we might need to do a little bit of work here. Let's figure that out. We got 6x squared. Oops, let's make this into our LaTeX form. 6x squared minus 6x minus 36. We want to set that equal to 0. So I think the first thing we can do is we can factor this, but it looks like there's a common factor of 6 all over the place. So let's first take out a 6. So if we factor out a 6, we're going to get x squared minus x minus 6. And now if we're looking at this, maybe we can just factor that with, I don't know, an x minus 3, maybe. X minus 3, and then x plus 2. So let's check this to make sure that this factors properly. We got the first term's x squared, the last term is going to be -6, and then the middle term is going to be -3x, and then we have a plus 2x, so -3 plus 2 is -1, so this looks like it's it. So we have x values of +3 and -2. So -2, 3. I don't think the order matters. Enter your answer as comma separated list, so I think that's fine. Now -2 and +3, are they within this interval -3, 4? It looks like they are, and so we're going to want to find the y values at the critical point and at the end points. So we weren't able to eliminate any of the critical points because they both fell within our interval. So what we need to do is we need to find out what happens in the original function. We want to find out what happens at the critical points at -2 and +3, as well as the end points at -3 and +4. And so for that, I had my spreadsheet ready, and I'm going to use Excel or something like Excel, and I'm going to put the x values in and the f of x values. So the x values that we want to put in are -2, 3, -3, and 4. And so how we're going to do that, the function is going to be, this is where we get to take advantage of the functions in Excel. It's 2 times x squared, and our x here in this case is -2 for the first one. So let's take it to the power of 2. And then we have a minus 3 times, I'm sorry, the first one is x cubed. So let's be careful with that. X cubed, and then we have 3 times the x value raised to the second power. And then we have a 36, -36 times the x value, just raised to the first power, and then we'll throw in a plus 8. Plus 8. Okay. So the y value of that is 52. Now I can retype everything over, but the nice thing about these spreadsheets are you get to take this and then click and drag down so you can populate the answers for these specific y values or x values. So it looks like when x is equal to 2, y is equal to 52. When x is equal to 3, y is equal to negative 73. When x is equal to negative 3, y is equal to 35. And when x is equal to 4, y is equal to negative 56. So those are the values that we get at the critical points. The first two are the critical points, and then the last two are the endpoints. So between these values, what we want to do is just look at the smallest and largest value. So therefore in the interval, the absolute minimum is at, let's see, the negative. So be careful of the negative. It's actually negative 73. And the absolute maximum, the largest value here, is positive 52. And as always, it's worth looking at the graph of this. So let's take our function here and see if we can graph it. So our function is y is equal to 2x to the third power minus 3x squared minus 36x plus 8. And here goes our function. Now we want to restrict this. So let's restrict this to go from minus 3 x values to 4. I think that's our restrictions. And if we take a look at this, let's do another zoom. Let's adjust our window. Let's keep the y-axis okay, and let's restrict the window from maybe negative 10 to 10 or something for our x-axis. So we see that here, I guess this should technically be less than or equal to. That doesn't matter too much. It just, when I was dragging this, I saw that it was undefined, but now if it's equal to, then we can actually see it defined at 35. And this is at 52 that we saw, and then down here was at negative 73 that we saw, and then up here is at negative 56. So the maximum and minimum looks like they happen at the critical points. So it's a good thing we took a look at the graph so we can straighten out our thoughts and ideas about this particular function. Okay.